Okay, so let's talk about relational studies. And these notes are available on the Canvas site. So if you want to look at these notes and follow along with me, that's fine. So the first couple of slides that you're going to notice is there's a lot of different types of decision trees out there, looking at your variables, your means, etc. And we're going to talk about some of the terminology in a minute here, but understand you have your t-test, your z-test, regressions, chi-squared. So get used to, if you're reading an article and they say they ran a chi-square, they ran a t-test, they're looking at a population mean, they're comparing means, etc. So once you sort of understand the type of test and what it's looking for, it's going to better inform you as you move forward. And the same thing with this type of decision tree. We're looking at more of the ANOVAs. So is it a simple, is it a one way? Is it a multiple way? Is it repeated measures, etc.? So starting here, if your factors, one factor, two factor, in between, within, subjects, and we're going to talk about all these terminologies mean, but again, getting an idea of how you can use a flowchart to help you as you're going through your articles. And then something like this, which is a little confusing, but it makes sense. We start way over here on the left. Again, we take our dependent variable and we see how that is negotiated through the tree. One thing I want to mention now is this is a good example. There's a lot of statistical tests out there, and we don't know them all. At least I don't know them all. And that's fine. I mentioned it earlier. If you don't know a test, you're confused with a test, etc., look it up, find some more information about it, like a Spearman's, a Mann-Whitney, a Friedman's. They're out there. There are all these different types of tests. Don't get so confused if you come across a test that you're not familiar with. Just do a little research on it, and it should help you understand as you read your results, etc. So when we talk about relationship in relational studies, you basically have your experimentals, and there's two types really, the randomized and the quasi-experimental. In the randomized, you're trying to measure the intervention effect. So you're going to have your intervention group, your control group. You can compare them, or you're looking for a relationship between them. Usually it's a pre or a post design, or something happens. So randomized is the best way. If you remember way back, we talked about OR biases lecture. The best way to get rid of any of the bias was what? Randomize and blinding. So this randomized concept, the concept of using blind randomization, is huge when you talk about relational studies. So keep that in mind. A quasi-experimental is the intervention comparison group, but they don't randomize. You want to see if they match up well, but you're not randomizing them. So it's kind of quasi-experimental. It's not a true randomized control trial. Common statistical symbols. And if you're going to take another stats course, you're probably going to get more of this. But I just wanted to give you a heads up just in case you saw any of these and you kind of knew what they were. And again, you're going to have these available on Canvas, so feel free to read them on your own. But as we're going through your articles, you're going to come up across these different symbols. An F-test, your null hypothesis, big N versus little n, a Pearson correlation. We'll talk about correlations coming down, your standard deviation, your variance, and then your Greek symbols, your significance level, which is your type 1 error. So if you see alpha, you're thinking type 1 error. You see beta, you're thinking type 2 error. And type 1 error is your false positives. Type 2 error is your false negatives. Your chi-squares we talked about in the previous section. Population mean, degrees of freedom, your Spearman's correlation, summation, your population standard deviation and variance, which you're going to notice that deviation and variance are basically the same thing, except variance is a square of the deviation. Your Kendall's correlation, and then your effect size. So get used to these symbols. If you want to print this out and keep it as a handy cheat sheet, that's fine too. So we're going to go through more of this. And when I was putting this together, I was trying to put it in a way that would make sense to a consumer. So the left column here is when the article says this, I try to interpret that for you as a consumer, okay? And they're numbered to correspond to each other. So when the article says alpha equals 0.05 a priori, we are setting our confidence level at 95%. So 95%, 0.05. So if it was 0.1, it would be 90%. We are willing to be wrong 5% of the time. So before the study starts, which is the a priori, we are willing to be wrong 5% of the time, and we're hoping to be 95% confidence we will not make an error with this study. So that's why they set the alpha level before they start testing. All right. Between subjects, difference between each of the subjects. Within subjects, difference with the same subject over time or trials. So this is if you have 4 people, between subjects is the difference between those 4 people. Within subjects is one person doing 4 different trials. All right, between versus within. You're going to see that when we talk about ANOVA. Your power, the probability that you will reject the null hypothesis when you should, meaning you're going to avoid your type 2 error. Go back a slide. And typically power should be 0.8 or greater. So they should report a 0.8 or greater power. But power is really a statistical test. The big one you want to see is effect size. Effect size is more practical because it gives you practical significance rather than just statistical significance. All right, so even if you have good power, it might not be practical, and however that is defined within the study. So effect size is what you really want to see. Your p-value, how likely the data is assuming a true null hypothesis. So that's why they set their p-value. And let's say after you do all your results, the p-value is 0.04. You would attain the difference between the groups in 4% of the studies due to random sampling error. All right, and what that means is that your 4% of studies, you're going to get an error. It's going to be due to random sampling, not because of a true difference between the groups. So when you see this stuff starting off, the language that you're going to see in the articles, this should set you up for it. Validity. We talked about it earlier, but here's a review. Validity. The instrument was valid. It means the instrument measured what it was supposed to measure. If it had content validity, the instrument measured all the facets of the concept, like an IQ test. The IQ test should be measuring all the things that is needed for IQ. If it has construct validity, that means all the test items conformed to the same construct. All right, so if you have 20 items and they're all supposed to get at how physically fit you are, that's construct validity. All right, and criterion validity is the instrument corresponds to another measure. The classic example is skin fold versus hydrostatic weighing. Okay, those are both 2 different ways of measuring body fat. So criterion validity mean that they measure up very well together. Reliability. If the instrument was reliable, it means it had consistent results. Intertester, 2 or more raters doing the same measure. The E for inter is for external people. Intratester, 1 rater multiple times. The A in intra is for autobiography. It's the same person doing it over and over. A little mnemonic device, if you will. Pearson interclass correlation. It's the relationship between the 2 measures. A correlation is a relationship or an association between the 2 measures, okay? And then the interclass correlation, you'll see the ICC reported a lot. That is the degree of agreement among 2 or more ratings. All right, so if you have a whole bunch of rating scales, they're going to run an ICC or interclass correlations to see how well they agree. Okay, so between validity and reliability, you have all these different subsections. I'm not going to go into great detail on it, but I just want to give you a little primer. So when you're reading the articles and they throw out intratest for reliability and they ran an ICC, you have an idea of what they were talking about. All right, when the article says mean, median, and mode, mean is the average, median is the midpoint, mode is the most frequent number. These are all considered the statistics essential tendency, which they usually report, or at least they should be reporting. Statistics of variability. When they say interquartile range, the IQR, this is the dispersion of your quartiles. And this gets into, you probably all saw this when you applied to grad school. Let's say you scored in the 65th percentile. What that means, if 100 people took the test, so let's say your GRE, you scored in the 65th percentile on your GRE. If 100 people took the GRE, you scored better than 65 of them, and you scored worse than 35 of them. All right, that's what the percentiles mean. And there's a first quartile, a second quartile, third, and fourth. All right, so if you're talking about percentiles, it's just where you would fall if 100 people, just for the ease of 100%, where you would fall in that. Your range is the highest to lowest. Standard deviation is how far an individual scores vary from standard unit lengths. And this is where you get that nice normalized curve if you've ever taken any sort of introductory stat course. you assume the data is normal, then 95% of all the scores will fall within 1.96 standard deviations of the mean. So if you have a 95% confidence interval, that means that the data is going to fall 1.96 standard deviations off the mean. And your variance is just the standard deviation squared. All right, so basic variability, basic reliability, validity, moving forward. Now we're getting into our inferential statistics. Now, the inferential statistics basically means you're comparing sample data to population data. And this is where it gets a little bit weird, but you're never really ever going to test an entire population. What you do is you take a sample and you hope the sample is representative of the larger population, and then you make your generalizability. So instead of measuring every single person who ever tore their ACL, you take a sample of people who have torn their ACL, you hope you can match the data, and then you make a generalized comment. All right. Parametric statistics is data is either interval or ratio. The sample relates to the population, and the population has normality. And this is what I just talked about. You assume normality, which means the sample can relate to it, which means you can make generalizability, which means you don't need to test the whole population. In non-parametric statistics, which I don't deal with much at all, the data is nominal or ordinal, and there are no assumptions of normality. Now, if you need a quick review, go back to our units where we talked about the different types of variables in review: interval, ratio, nominal, and ordinal. Understand what those different types of variables means, and including that discrete, continuous, etc. So make sure you understand the type of variables that they're talking about. So let's talk about statistical tests. All right, and this is when they're testing the difference of means. When the article says a paired t-test, that means the difference between two related variables. The variables are related, therefore they're paired, and they ran a t-test on them. If it's an independent t-test, they're still looking for the difference between two variables, but the variables are independent and or unrelated. All right. An ANOVA, which is an analysis of variance, that's the difference between two or more group means. Technically, though, it's really the difference between three or more. What you're going to find, if it's only two groups or two variables, you're going to run your t-test. If it's three or more, you start to run ANOVAs. General rule of thumb. You could, in theory, run a ton of t-tests, but that's why you use the ANOVA, because you have more groups. If you have more groups, you're going to run an ANOVA. A one-way ANOVA, one factor being analyzed; a two-way ANOVA, two factors being analyzed. So if you go back to that compression stockings article, they ran a one-way ANOVA where they only analyzed one factor, and they ran a two-way ANOVA, meaning they looked at two factors. But because they ran an ANOVA, you do that they're looking at more than one group, or more than three groups, I should say. That makes sense? So they looked at multiple groups, but only one or two factors. All right, so start putting that back into the context of the compression article. When the article says correlation, that's the association between variables. Understand, correlation does not mean causation. They are not the same thing. Just because something is correlated does not mean it caused it. A Pearson correlation is association between continuous variables. Spearman uses ordinal, and a chi-square uses categorical. Again, if you are confused on the variables, then the correlation test won't make any sense. So go back through and review your different types of variables that they're using. All right.